Okay, this is a lesson on interior and exterior angles of polygons, and you can see what I've drawn here is a triangle that I've extended the segments past the vertices of the triangle, and this ends up displaying the exterior angles. These blue, well, obviously the green angles are the interior angles, and the exterior angles, as if I continue and complete till that segment I've extended past the vertice, and you'll notice that each interior angle plus its exterior angle equals 180. So that's one thing that's very important. So each pair of interior and exterior angles, so each pair of interior and exterior angles are supplementary, so they sum to 180. Now, next thing I'd like to show you is how we can find what the sum of the interior angles of each polygon are, and then we'll go back and explore exterior angles some more. What I've done here is I've noted a vertex here. You could do this by starting from any vertex, and you'll notice what I've done is I have joined that one vertex I've selected with all the other open vertices. I can't create a triangle by going to this one or to this one, but if I to the other open vertices, I create these. You can see I have 4 triangles. Now, remembering that the sum of the interior angles of each triangle equals 180, so far, in this triangle right here, I've accounted for 180 degrees of the total angles of the hexagon here. So I've accounted for 180 degrees. That's this angle, part of this angle, this part right here, all of that angle and part of that one. Now this next triangle I've drawn completes this angle, part of that one, and a little sliver of that angle. That's another 180 degrees. Then so on. I've got these other 2 triangles. This one creates accounts for part of that angle, part of that one, and part of this one. And then the last triangle I have created accounts for all the angles of the hexagon. So these 4 180 degrees account for all of the interior angles of the hexagon. So what I've discovered is that in a hexagon I could create 4 triangles that allows me to see what the sum of the interior angles equals. It's 4 times 180, so 4 times 180 equals 720 degrees. That's the sum of the interior of a hexagon, sum of the interior angles. Now, that allows us to understand this formula, which is n minus 2 times 180. N's the number of sides or the number of angles. It's the same. So for a hexagon, for example, I can create 2 fewer triangles than the number of sides. So that's 4 times 180, and you can see that gets that 720. So I don't need to draw triangles inside the polygons. If I want to find the sum of their interior, I just use that formula. So let me scroll up now, and let's take a look at our next formula. So if I'm talking about a regular polygon, considering this, I'm telling you this is a regular polygon, in this case a pentagon, I can find what each angle is of the regular, in this case pentagon, if I know the sum of the interior, because each of the angles is going to be the same, Therefore, all I have to do is take the sum of the interior, divide by the number of angles, and I can get what each one is. So for a pentagon, I've got 5 minus 2 times 180. That gets me my sum of my interior, which is 540. Sorry, that's going to be a 5 there. So I have 3 times 180 divided by 5, and so that's 540 divided by 5, which is 108 degrees. That's what each of these angles will equal, 108 degrees for a regular pentagon in this case. But I can use that for any convex polygon, any regular convex polygon, to find what each angle of it is. Now, going back to exterior angles, I've written another triangle here, and what I've noted is that, let's say you have a 30, 60, 90 triangle. I've noted the exterior angles, and for now I just want you to realize that the sum of the exterior of that triangle, and by the way, that would be true for any triangle, the sum of the exterior angles is 360 degrees. Notice I made a little rhombus here, and or actually it's a little parallelogram, and I've noted angles of 70, 110, 110. Their exterior angles are also 70 and 110. Notice that the exterior angles sum to 360 again. So both for triangles and parallelograms, we realize that we still have a sum of exteriors 360. If I look at I've drawn up a little pentagon here, and I used a regular one. It doesn't have to be regular, but just so I can display what the sum of the exterior is, notice that each of the exterior angles is 72. If each interior is 108, 72 times 5 is still 360 degrees. So that tells me that the sum of the exterior angles So what I've written here is the sum of the exterior angles for all convex polygons is 360 degrees. So there's no formula. You can always assume that. And they don't have to be regular. So now, if it is regular, though, if you are talking about a regular polygon, you can find what each exterior angle is. Since you know the sum is 360, the formula is simply 360 divided by n to get what each angle of a regular polygon is. And so let's say I was talking about a quadrilateral, I'd say 360 divided by 4, so that's 90. So each exterior angle of a square, for example, that's a regular quadrilateral, is 90 degrees. That's just one example. So let's look at some problem solving now. So what is the sum of the measures of the interior angles of a convex heptagon? Well, I'm going to use my formula n minus 2 times 180. So that's 7 minus 2 times 180. So that's 5 times 180. And that's equal to 900. So we're going to use our formula. Remember, this is, we're going to use our formula n minus 2 times 180. That gets us the sum of the interior divided by the number of angles. Remember, we have 18 minus 2 times 180 over 18. So you have 16 times 18. Times 180 over 18. So this cancels to get a 10. So you have 16 times 10, or 160 degrees is what each interior angle of a regular polygon with 18 sides has. Okay, for this one we're finding the number of sides of a regular polygon with an interior angle measuring 120 degrees. So the way we do this is we got two ways. We could take our formula for what each angle is of each interior angle is of a regular polygon, and set that equal to the number of degrees that each angle equals, and then solve for n. You may need to set this up in proportion form so you can kind of see that you need to cross multiply here. So I'm going to go 1 times this and n times this, and then when I multiply 1 times this, I'm going to go ahead and distribute. So that's 180 n minus 360 equals 120 n, and then subtract 180 n, subtract 180 n, and I would get negative 360 equals negative 60n divided by negative 60, and I get n equals 6 sides, so it's a hexagon. Now the other way I can do this problem is I can say that, well, I know the sum of the exterior angles of the polygon is 360, divided by n would get me what each exterior angle equals. Well, if the interior angle is 120, that means the exterior angle is equal to 60. So again, thinking cross multiply again, 360 times 1 equals 60 times n. So that's a little easier to do it with the exterior angles formula. So n equals 6 sides again. So in this problem, you have home plate is on a baseball field, has 3 right angles. The other 2 angles are congruent. What is the measure of one of these obtuse angles? So what they mean here is that this is a right angle, that's a right angle, and that's a right angle. These other 2 angles equal x. So if you, and you know the sum of the interior of a pentagon is, sorry, let me not skip to that. It's 5 minus 2 times 180, which would be 3 times 180, or 540. So that's my sum of the interior angles. Now I have to use a little algebra. I have 2 times x plus 3 times 90 equals 540. And so I would have 2x plus 270 equals 540. So minus 270. So 2x equals 270. So divide by 2, and I get that x equals 135. So each of those angles equals 130. Each of those obtuse angles equals 135. In this problem, a regular polygon has an exterior angle of 30. How many sides does the polygon have? Again, these are pretty easy because you have 360. That's the sum of the exterior for any polygon, any convex polygon, divided by n equals 30. So 30n equals 360 divided by 30. So n equals 12. So that's a dodecagon. All right, an equiangular polygon has an exterior angle of 40. So how many sides does this polygon have? Well, the only thing it didn't say regular, but it wouldn't say equiangular if it's not an even-sided polygon. So so this really means regular, so don't get thrown off there. So 360 divided by n equals 40. So 40n equals 360. So divided by 40, you have n equals 9 sides. Last problem in the notes. A regular polygon has an exterior angle measure to interior angle measure ratio of 2 to 3. All right. So so the first thing we want to realize is that if you have a 2 to 3 ratio of interior exterior angles, let x just be your multipliers, but you know that the sum of the interior and exterior angles equals the sum of each interior and exterior angles. So since those are going to be the same for a regular polygon, you can just come up with, like, this would be one of the interior angles, and, I'm sorry, one of the exterior angles, this is one of the interior angles, and so you're going to have 5x equals 180, so divided by 5, and you get x equals 36 degrees. So that's actually your multiplier, so you don't even really need to think of degrees there. So you have 2 times 36, so the exterior angles are 72. And so if the exterior angles are 72, you can say 360 divided by n equals 72. So 72n equals 360. So divided by 72 is equal to 5. So that means we were dealing with a pentagon here. And that's the end of the lesson.